Okay, here we go. The recording has been started. Rasmus, the floor is yours. Take it away.
Awesome. Thank you. Let's see. I should share my screen. All right. Here we go. All right. So as I was saying, hello everyone. I'm Rasmus. I'm the design captain for No Mythic. And so here is a little slideshow that I put together. So today we'll be talking about running an effective pit and design process. When looking at a maintainable robot, those are sort of the two main points I think of, is how do you design a robot so that it can run effectively and can be maintainable, but then also how do you actually maintain that during a competition? Um, and so to start off, I want to quick talk about our pit process because with state coming up, congrats to all the teams that made it there. I wanted to quick talk about how we run our pit and then open the floor up to anyone else. And then hopefully jumping into the design process a little bit. So starting off, I want to talk about what our pit consists of. So our pit has 5 villagers at a time. So that's 3 full-time, one of those is a lead, and then 2 rotating out. Along with 1 to 2 programmers, so similar, 1 is full-time and then 1 is rotating, and then 1 to 2 mentors, depending on how the robots look and stuff like that. And then as for another role, we have the pit guardian, and this is a role that talks to judges and other teams. So when the robot comes back after a match, there's going to be a lot of chatting within the team about what's happening, what broke, what didn't, stuff like that. And so the Fit Guardian allows us to have a outward-facing person talking to other teams, talking to judges, and helps allow the people in the pit to stay focused on the work there. Um, and with that, I'd like to quickly go over our how we run the pit for sending or between matches. And so we run a pit check, but before then, after each match, we have a drive team debrief. So this is where the drive team and all the pit, they all come together right after the robot comes back to the pit, and we talk about what went well in that match, right? Let's say the shooter worked great. That was really good. The intake was working, but the climber was a bit sicky going up or something like that. Um, and so it's just a little time for the drive team to talk about during the match what they saw and stuff. And one of the reasons that we implemented that was because in years past, the drive team would come to the pit and it'd be like, "The robot's broken," and the pit looks at it and it's like, "I don't see anything broken." um, so it sort of helped mitigate that issue, and it has worked really well for us the past few years. And so from there, then the pit, they go fix those issues. So in the example that the shooter worked really well, the intake worked really well, but the climber didn't, we would then have some people looking at the climbers, like seeing what's working, what's not, and diagnosing that further. And then once all those issues are fixed or at a good enough spot where we can move on to other stuff, we run a very thorough pit check. So we start off with the systems off check. So this starts with having 4 pit members or 4 build pit members looking at the robot and then the lead telling them what to look at. So as you can see on the right hand of the screen here is our pit check system. So we go through each system. So in this we have drivetrain, and then each person checks a swerve module. So each person's going looking at their own swerve module as the pit lead is sort of guiding them through what to be looking at. And so we check, are the treads good? Are the motors secure? Are the gears, are they all looking good? Is the wiring looking good? And so we're looking at that for each of our systems. So our drivetrain, our shooter, the big gear, which is just what the shooter runs on, the climber, and the intake. And then this we update every year and make it very customized for each year. And then we also on here, we have a bumper check. It's always unfortunate when you go to a match with the wrong color bumpers. So this is a way to help avoid that issue. And so after we have a full robot on check, then we jump into the robot on check. So this is all the systems mechanically are working. Now I want to make sure that the code is working with them as well. So we turn on the robot, we tether it in the pit, and then we drive forward, back, test the drivetrain. We test the shooter, the climber. We test all our systems as well as we can in the pit. And this just helps us make sure that when we're sending the robot to a match, that everything is working as best as we can test it. And so this year, this has worked really great for us. And we have gone to pretty much every match with a working robot. Yeah, and so that's a bit about what Nomythic has done. Now I'd like to open it up to all of you, and see what has worked for you. Have y'all done similar things, different things? Like what are all of y'all's processes?
So on Talent, we kind of have like the exact same thing. We have like a stationary pit crew of maybe like 6 to 7 people, and then we like to rotate 2 people into there at a time. Usually we like to do like lesser experienced members who don't really get into the pit very often and get them more experience, kind of get them the feel of the pit. And also they're usually pretty good help when we just need hands in the robot. We also have the exact same like kind of pit checklist system of just a list that we check off, running things. We just call it systems check. We run everything, check all the like gears and stuff, bolts, tighten everything down, power everything up, and then test all the working components with it on. So I don't know. We don't really have very much different from you guys.
That's awesome. Yeah, thank you for sharing.
No problem.
I'll say for KnightKrawler that very, very similar process for a pit checkout, ops test checkouts that you have here. I do think that every other match or every 3 matches, we verify every bolt on the swerve drive modules are tight. So I think we're doing that every other match or so, where we're actually putting an Allen wrench on the bolts and the swerve drive and making sure they're all tight. And then occasionally if we see something weird happen in a match, occasionally we'll verify the gyro as well. And sometimes a gyro check where you turn the robot on the cart, that's included. It depends on the year too. Sometimes for Rapid React, we used, I forget what it is. It's a pitch, I think. So because the robot would swing, so we actually pick up the robot and we test to make sure the gyro is running correctly that way too. So, but very, very similar to what you've got here.
So, thank you. Yeah. See other. Oh yeah, Jeremy, go for it.
Blaine 2181. We, because of all the autos we were monkeying around with, we ended up adding an auto selector check, like as one of the last check marks on our piece of paper, was because multiple times at the week zeros we went to, we put the robot down and it would not do what we thought it was supposed to do because we didn't select the right one. So and every year I know the auto, this year there was a lot of autos. Different years there might not be as many, but we ended up adding that to ours.
I was going to chime in from Fairmont Megahertz 2847. Last year at Worlds, we actually got to play with 254. So they came around to our pit beforehand and kind of gave us their pit checklist and kind of held our hands and walked us through it. It was optional, but didn't feel super optional. But we learned a lot of good stuff from that. One of the ones we learned was running the auto on the cart. Like actually having a way you can run your auto. And we've been doing that. It's loud. Like this year is especially loud, but it's kind of nice to watch all of your mechanisms kind of move and you watch the wheels spin and turn. And if something's locked up or anything, you can kind of check it. And so we're probably going to expand that to like trying to run every subsystem a little bit on the cart in some safe way, just to really watch. And actually listening, you can learn a lot too from if you hear something kind of ka-chunk or whatever grinding. And so we're not super formal, but that's on our list anyway.
And that actually brings up a point that I want to mention. That is really nice about being able to like use your drivetrain on a cart. This year we made a custom little bit with our robot this year. And one of the issues that we experienced in match was the can coder was dead. And so being able to run that check allowed us to see that that can coder was dead. So I think that's a really, really good thing there.
Yeah, you guys had like was it like nylon or something, like a little like cup on your cart that would like hold the swerve module wheels?
Yeah. Clay, do you want to speak to that?
Sure.
You did a lot of the design work on that.
Yeah, we had a unique situation where we had a lot of stuff mounted to the belly pan of our robot, and there weren't a lot of safe places to like rest the robot frame on, so that the wheels were not on, so that it wasn't resting on its wheels. And it was just, we were worried about breaking that stuff as we put it on and off the cart. And so the robot was sitting in a set of, each wheel was in a cup. And since it had cowlings over the wheels, it wasn't able to climb up out of the cup, but we also didn't want to like burn through the bottom of these cups. They're just 3D printed. And we ended up putting adhesive back Teflon tape on the bottom of this cup. And so the thing kind of just spun on ice, basically. And we didn't run it at full speed on the cart. And there's a better way to do it. I'm actually interested if anybody else this year who was doing under the bumper intake or had a lot of stuff on the bottom of the robot and had swerve drive. How do you like mounting your robot to the cart? How do you get around that?
Did No Mythic have a frame that extended down to the belly pan on 2 sides or 4 sides?
I mean, I can quickly pull up a picture of our robot, but our intake was down on one side, and then in the middle we had our gyro, which was an interesting little design thing, but it worked actually pretty well having the gyro down there, because then we also inverted the Mark IV inverted modules, so we made the Mark IV I squared modules. And so our belly pan was actually 4 inches off the ground. So kind of interesting.
Oh, yes. That makes a lot more sense about why you would be concerned then. Yep. I get it.
And
yeah, we had our belly pan at 3/4 of an inch off the ground or 1/2 inch off the ground. So we had solid frame on 3 sides that were low. So we could rest it on. Our cart has a 2-inch 80/20s, and then on that we have wood 2x4s that we can slide wherever it works to fit it between the wheels. So we can rest it on that, but we didn't have the situation that you guys have where you're up off the ground and you have intake parts that are dangling down below. That makes a lot more sense.
Yeah, and that's actually something that we're looking at right now is a new robot cart, and especially one with a top area that can be made specific for each year. Because that's something that we sort of came across this year was, you might need a robot cart that is specific to that robot. Which ideally a robot would work on any robot cart, but that's not always the case. Awesome. Well, are there any other questions about Pit and any of the stuff there? Awesome. With that, let's move to our processes of design. So I will reshare my screen here. And so this year, we started what we call the No Mythic pattern language. I think I mentioned this before, but I'd love to go over it in a little bit more depth here. because we've learned a lot through this, and it's been amazing using it as a tool. And so this was actually at the start of the season. We chatted with KnightKrawler, and we learned a lot of really good tips there. And we sort of put all the processes that we had and anything that we wanted to change in here. And the big one that I want to go over first is the principles section. I can actually probably drop a link to this in the chat if anyone wants. But this is sort of split into 3 sections. It's our design process. So like, how does prototyping and all that other stuff fit in? And then practice. So this is sort of what have we worked, or what have we done in the past? What's worked? What hasn't? This also includes a design bank of a bunch of systems that have worked well in the past. And then the one that I'd like to start with, which is the principles section of this. So these were a few sort of design guidelines that we set out at the start of the year that seemed to work really nicely. And so the first one, for example, when designing, we wanted a very replaceable design. And so with this, we have a little description of what that means. It's like a modular design with quick swap abilities when possible. And then all elements of the robot are easily accessible by hand or tool. And then all parts have part number, excluding the year description when possible. And that's a bit more specific. But this year, our robot was very modular, which was very helpful, unlike years past. So for example, we had a week 3 scrimmage where the robot fell off the table, or off a table, and we bent up a bunch of our robot. It was a very sad day, but we were able to just pull the climbers and shoot her right off with just a couple bolts, and it allowed us to have a 4-day turnaround off of a situation like that. And then in years past, we haven't had a very replaceable system. Like last year, we had a big old arm, and that mid-competition, we had to take a saw to our belly pan. So making a modular design was something that we learned from and works really well. And then I think, I'll probably just go through each of these quickly and then open up to discussion. So the next data principle we set out was simple, so that all systems are simple in some way. And so we put in a chart here about what simple means, and that there's build simplicity and programmatically complexity. And so you can have a system that's very simple, or from a mechanical perspective. Like let's say, there's a really good YouTube video about this from many years ago, but you can have a system that's very simple build, right? Let's say you're turning a motor for some operation, right? But from programming, that can be very hard. On the flip side, you can have 17 motors for build, which I guess would also be probably tricky programmatically. But anyway, it's a nice little chart that you created that helped us sort of understand what it means to make a simple robot. The next one is durable. So we want all of our systems to survive and be strong, or be not, or be very flexible and able to take a hit. This is something that we saw in 2022 when we hit our intake every match, and it would bend down a little bit each match. And then the next one is realistic. So again, cantilevered parts aren't great. This is also very true for Neo 550s. This is something that we saw this year, that those shafts love to break. And so we love having things all supported and everything nice there. And then we have 2 on here sort of about hardware. So one about limit switches, having everything limited in the design is really helpful. So that's limit switches, any Hall effect sensors, any limelight, stuff like that. And then part specific, so making sure that all parts they have tolerances, and they're either let's see, how did I phrase it in here? So they're either symmetrical or clearly asymmetrical. It's always unfortunate when you have a part that's very similar and then it gets put on wrong. And then the last one is hardware planned. So electronics are a huge part to have in the design process. And so we've made sure to really bring those into the design and include all of that. And so those were sort of the main parts of the design that we were looking at this year. Let's see, does anyone have any questions about that? The things that they talk about their design? Yeah, go for it, Paul.
I was just curious, what do you guys define as like simplicity, like in terms of hardware? Like, do you define like extra rotations or like degrees of motion as more complex, or just having a more complicated design that you haven't worked with?
Yeah, so complexity is always one of those tricky terms that kind of varies year to year. I think the way that we saw it is this year we have a shooter that is just one bar or one arm going up and down. And that, from a build perspective, is what we consider a simple system. Whereas last year we had a double jointed arm, which we consider a complex system because it has multiple moving parts and a bunch of stuff there. And then with that, it also comes into like how you're actuating it, right? If it's a pneumatic, that's fairly simple. If it's a lot of gears in a gearbox, that's a bit more complex. Yeah, I think that's at least how we sort of consider it. Does anyone
Okay,
have
thank
anything
you.
to add to that?
I'll add that simplicity of repair on build is also a big one, because a big problem with the gearbox that we talked about last year is that it was also very compact, making it super hard to fix something if something did break.
Well, let's go to Aerobots. Do you have a question?
Hey, question here. What do you guys do to make your 15 motor controller wiring, green and yellow wiring, not look like a hot mess that will get caught up in everything? That if anything remotely bumps your robot, so the wire doesn't come flying out of it. It's just, what do you do? Do you put things in sleeves, or I don't know?
Yeah, this is something that we've not always been great with. And so, no Mythic, we do an odd thing where we make two robots. The first one, we don't necessarily make the wiring pretty, but for the second one, which we compete with, on that one, in the design, we design paths for them all to go to. So, like all the sort of modules, they have a very specific part that there's like a hole in some box tubing and stuff that they can fit through. And the shooter, that we have some cabling, or some like cable protector around a big bundle that goes up to all those motors. We also love zip ties and little sticky pads. Those are very helpful. But those are some of the just basic things. I'll just throw it over to Clay here as well. He does a lot of our wiring work.
If you don't mind me adding one more thing before Clay, let's talk about sleeves, right? One of the biggest problem that I try to warn my students about is making sure that your wires don't interfere with each other. The bigger gauge with smaller gauge. Do you think is that a sleeve that they can use to limit that from happening? So let's say you had a whole bunch of CAN bus wires that can go down, but then if you have you have a bunch of 12 gauge wires that can also run along that same path, but they're in different sleeves. Is that a feasibility, or is that my wildest imagination?
Is your question that is the sleeve going to serve to insulate the signal
Insulate
wires, like your
yeah.
CAN wires, from your power wires?
Yeah.
It's not going to, as far as like interference, it's not going to do anything. But things that you can do to keep power wires from interfering with signal wires are to keep them separate.
Yeah.
have them cross at right angles rather than run parallel to each other. And if your hand wires, if you keep them twisted, like a nice tight twist, that can act to cancel out some of the interference. I'm sure somebody with more electrical education can say more realistic things about that, but twisted pairs go a long way to keeping noise from affecting a CAN bus, for example. Does that answer your question?
Yep, it does. Thank you.
Oh, and then this message in the comments as well.
Yeah, I can read it if you want. So I'm Carly. I'm the lead mentor for Pure Robotics Team 2500. This year, our team did focus on having a robust robot. It was like our #1 priority, but we didn't focus really at all on wiring. Everything was wired in this like 2 cubic foot section underneath the shooter, and we only had it be a problem once. We use cable ties, Velcro zip ties, so that we can adjust quickly, and that was an improvement over last year where we had to cut like 7 zip ties every time we wanted to change any part of the wiring. So being able to reuse and loosen stuff as necessary was really helpful.
Velcro's a great idea. Rasmus, we should do that. I've cut so many zip ties. So I think yeah, go ahead.
No, and plus the risk of running zip ties, we almost ran into that. Is you also run a risk of nicking a wire that, and then you got a bigger problem now. Not only that you have to fix the initial problem, now you created one more for yourself. So that, and the other thing we ran into in Granite City was one of our walk connection with the CAN bus ran right on the belly pan, but crossed over to go on the other side of the robot. But then behind that was directly behind the battery tray. But when that battery, we had a big bump, and that battery got pushed into that cable, and so then it broke the insulation. And because the robot was perfectly working, suddenly it just sitting there blinking, nothing showing up on the computer as to why we could not run our robot. And FT is like, you look good on here, but then when we got back, checking the whole CAN bus, that wire was nicked because the battery bumped it so hard that it nicked it, but it was in the insulation. But when you look at the bend in there, it was flattened so much that every time we pushed on that, and that's kind of how we diagnose that. So some of that is just, that's why I'm asking about the whole wiring and how to secure your wire, because it was a stupid reason to not play the match, really.
I will say that KnightKrawler has generally been a big fan of hot glue. We hot glue just about everything. And in situations like that, Jeremiah, you could run your wire on your belly pan, and then you could run a bead of hot glue along it so that it can't shift underneath the battery or vice versa. I was actually having breakfast with Firebears on Saturday, and they were mentioning that they had on their swerve, I think it was on their swerve modules, the factory connector that plugs into the motor housing. They were having so much bounce on their wire as they were driving that they were breaking the insulation right at the connector. And then because of that, then eventually they would get a short, or the wire would actually stress break as well. And so then they started zip tying the wire to the motor. And then I think Tyler said they also started hot gluing it as well. So it just simply couldn't move, because anytime your wire moves, if it moves enough, you're going to get stress fracture. And so hot glue and strain relief is your best friend everywhere, but then also hot gluing any place where things could just pop out. We pretty much everything in our rubber reel, all of our DIOs, all of the SPI connections, everything is hot glued into the rubber reel. Everything in the radio, the USB hub, everything's network hub, network switch, everything's hot glued in.
Yeah, we do something really similar. We hot glue all of our connections in, especially the Spark like encoder wires. We like hot glue those so much. But mainly how we run our wires, we have Wago connectors and we attach ferrules to all of our CAN wires, and then we put those together and we just use VHB tape in order to tape it directly onto the frame. And we try to have all of our wires be more open, just because we want to be able to change them quickly. We've had used a lot of snake skin in the past, and on those long chains, we actually ended up putting connectors on the inside of the snakeskin. And so when those connections break, it takes minutes for us to do that. So I think we just got a little bit scared of that. So we didn't actually put any snakeskin on our robot this year. But we did end up with one CAN failure in our finals. Our resistor that terminates our drivetrain CAN got clipped from outside the robot. So I think we're going to try to do more protected wiring next year.
Something we started doing with the various little plastic connectors, in particular on the CAN bus. There's like I think it is a JST SM connector. It's one of the small. It's like a black connector with a latch. It's the anyway. A lot of those connectors don't have a lot of strain relief on them, and they're weeny little wires to boot. We've started putting this UV curing adhesive, like little dabs of that where those wires meet the connectors, and then you cure it with a little black light flashlight, and it just sort of, it's like you're adding a strain relief to a tiny little plastic connector. It ends up, it makes them last a lot longer, and with little 22 to 30 gauge wires, they need all the help they can get. And I think Scott said something about strain relief, and I see situations where wires have failed, and more often than not, it's because that wire has been pulled tight one way or another, where it's being forced around a corner and it's sat there and vibrated forever, or it's like been pulled tight out of the top of its connector, and allowing a loose loop of wire coming out of every connector, and then anchoring that wire somehow. Like I'm thinking of on a Kraken, we have the power pole adapters for Krakens, and all the wires except for one sort of come down the side of the motor, and we tape them all onto that motor with a bit of gaffer's tape. Like, don't put the strain on the wire on the connector if you can avoid it. Yeah.
Hey Clay, are you talking about the Neo? Like we use the Neo, and the most annoying thing is that connector with the sensor wires come into. My kids have a way, and sometimes too it's a design flaw, because to push that connector in, sometimes you push on with the connection, the wires meet the connector, and we've lost a few Neos that way. And I think I had a conversation with Corey Applegate, and he said there was some kind of a repair kit that was out there, because without that, it's useless to use the Neo.
Yeah.
For
You're talking about the little white connector with 6 wires going into it.
Yep. So is there any
encoder wires?
Is that what you were talking about? Giving a
little
bit of.
That's one of the first ones that I started putting that UV adhesive on, and it makes a huge difference.
Are you able to, where do you find that?
Yeah, there are a lot of these. I will caution you that like a UV cure adhesive is the sort of thing you use gloves. You don't want it on your skin if you can avoid it, and just be clear with students who are using it that it's not good for you until it's cured, and then it's fine.
Okay.
See if I can find it. It's not cheap, but it goes a long way.
Well, if a $60 something motors keep filling out on you, because of that, it's
it's Loctite brand, and it comes in a tube. It's AA3103. I'll post it in the chat. Hang on. And on top of that, if you've got those motors that have got broken connectors, I'll post a link to on Amazon. You can buy a connector kit. That's just a whole bunch of different sizes of that type of connector and little crimps, the little like crimp contactors. So you end up buying a kit for $10. You end up buying a universal crimping tool for $20 to $30, and then you can repair them anytime they break.
Thank you.
You bet.
Yeah. And I don't know if y'all saw, but Scott also shared a great roundtable in the chat that was specifically about wiring. So if you have questions about wiring, I highly suggest checking that out as well. Let's see. As with this, are there any other questions before we hop into the next sort of section about process, about any of the conversations here? All right. Then I'd love to share a bit about, because sort of going through the process, I'd love to go over how we defined our sort of build process this year. So this was something that we looked specifically at this year, because we also go to Duluth, which is a week one competition. So that is a very fast turnaround. And so for each system, we sort of have a 5-step design process that we used this year that seemed to work really nicely. And so I'd like to share that here. And this is in that same document as before. But the process that we use here, or that we used this year, was that right after kickoff, we define our requirements. So what does the system need to do? How strong does it need to be? What size does it need to be? What's the speed? What's the output? And I think this was something that we learned from KnightKrawler, was some of these. I could be remembering that wrong, but I think that's the case. But then also the defining rough prototypes and precise prototypes. So at the start of the year, we started with a lot of rough prototypes. So this is with like 2x4s, drills, stuff like that. And then pretty quickly from that, we switched to more precise prototypes, which are your machine cut wood with motors, stuff like that. And then jumping into the final fabrication of the robot. But we found it very helpful to define these 4 steps. And then the other thing is that after final fabrication, there's another phase of iteration there. And that was something we saw with our intake this year, was that in Duluth it didn't work the best, but with the modular design that it had, we were able to swap it out and test other systems. So yeah. Are there any questions about any of that? Any thoughts, comments? Let's see. Go for it.
So with your prototyping, like your rough prototyping, are you literally just like grabbing a 2x4 and like setting up your intake? It's not like you're like catting it up or anything. It's just, let's see if this will work. Let's see if this dimension will work.
I mean, it can involve some minor bits of CAD, but it's not a whole lot of like designing a full system. It's like if you want to cut a few holes in something like that, for sure. And of course, if there's a system that you're liking more, that's when the lines sort of blur between a rough and precise prototype. But yeah, but I think intakes is a great example here of like if you grab just like some drills with wheels on them, that would be something like a rough prototype. We did make some jigs for some stuff, which was a bit more of that sort of rough area in between. Like shooters this year, that was sort of an in-between area where we made some rough jigs on our CNC router that had some different hole placements. So it really depends on what you're prototyping. Like the main idea is that rough prototypes are prototypes that can be made quickly within a practice, or within an hour or two. Yeah. Yeah, that's a really good question though. Let's see. I think that's most of what I wanted to share today. So if any of y'all have any questions about maintainable robots, or if any of y'all have realized anything or have any processes that y'all would like to share, go for it.
One of the things that KnightKrawler did really well last year with the cones and the cubes, and I think Talon came up to us and talked about it too, is they noticed that we only had one motor above the frame for our entire robot last year. And so we also had 2 pistons above the frame, but everything else was down inside the frame. And because of the nature of the game last year, there was a lot of contact inside the frame perimeter, a lot of damage inside the frame perimeter, wires that could get snagged. And so I don't know that how intentional we were about making sure to, the point you made earlier, Rasmus, about complexity and simple hardware, simple software is your sweet spot as long as you can do the things you want to do. One of the things that we did last year in a couple of different ways is we tried to keep things down low and safe. And then the things that were up in the air or that were subject, we would armor them. I mean, we had a pretty decent thick piece of aluminum on the back of a robot that was protecting our elevator motor that was just an inch and a half above the frame. And we ended up putting a license plate on it as just something stylistically fun to do. But it was this pretty big plate that was on the back of our robot just to protect that motor, which was easily inside the frame perimeter. And if someone had hit us, that would have been a penalty, but we'd rather not have the thing get hit and broke. And so thinking intelligently about where you're going to put things or how to reduce your complexity just so that you can protect the amount of critical parts that can be damaged can be important. You can't always accomplish it, but in places where you have a choice, choosing to have a robot that takes less damage, especially now, I think this year was one of those years where it was sort of eye-opening for a lot of teams that so much damage, so many high speed impacts, even with your things where the impact was purely bumper to bumper and people got severely broken. I think teams are going to be looking a lot next year about robustness of the robot.
I saw this at the beginning of our season. Rasmus and the rest of the design team were like, we want to intake under the bumper because there's going to be a lot of beefy robots out there with a lot of big motors and a lot of weight, and we don't want anything outside of the bumper that can get damaged. And they took that another couple steps further and really built a really tough robot that I saw take some big hits and keep going. And they were really thoughtful about where things went and how things were put together such that systems nearby each other reinforced each other. The elevator mechanism or the shooter angle mechanism, a big sector gear, was adjacent to the climber mechanisms, and they were all tied together. They were separable for repair reasons, but they all reinforced each other. And I think Nicholas is still on the call here. I have told Nicholas a few times that the shooter that he designed is like, it doubles as a melee weapon in addition to a ranged weapon. It's just so tremendously overbuilt. I think imagining the worst case scenario and then imagining what comes after it, that's like, I think something that goes into designing a reliable mechanism is like, what's the worst thing that could happen to this? And then how do we deal with that or the next worst thing after that when it happens? Could this thing survive that?
And The shooter did survive, I think, the worst thing that could happen, which was falling off the table. We ended up not having to replace parts on it. I think that where the overbuiltness made us suffer is we ended up being a bit too overweight to add a dedicated amp mechanism, making it so we've only really recently got our amp shot tuned to be exactly where we want it. And that's a little bit late, in my opinion, for that, given that it's in the off season now. But it did allow for the shooter to stay reliable, and we weren't concerned about it getting bent up or broken.
And the other point I want to bring up there is that one of the processes that NoMythic has really worked on this year was having subsystem leads. In the past, we've just had people sort of work on subsystems and stuff. But this year, we set out 3 specific leads. One to work on an intake and drivetrain, because they were very integrated this year. One to work on a shooter and indexer, because again, those were very integrated. And one to work on a climber. And so that helped all the systems be modular, but also it allowed for them to have specific people look at them. And then the role of the design captain this year was to sort of oversee all of that and make sure that everything's going together. And so it worked out really nicely having all those different sort of split up roles. So that's something that I think we'll definitely try again next year. But yeah. Are there any other questions?
I have a question for those teams that are building 2 robots, building their alpha bot and then their beta bot or their practice bot and their real bot, and maybe building 2 entirely different sets of mechanisms. KnightKrawler hasn't done that since Bag and Tag went away. We used to build with these 2 chassis, but sometimes I think twice we built a full robot. But I'm curious how those teams feel about that in terms of how it helps them, or if they're considering not doing that because they found it's hindering them. I think our design team is going to have a lot of discussions about that over the summer. And I'm curious to get feedback from other teams about how they think a second robot helps them, or if they're shying away from that idea, or maybe they already have.
So I can speak for NoMythic here, because we make 2 robots. I mean, they're pretty much identical, but it helps us for a few reasons, because we have a sponsor that does all of our parts, which is very nice, but it takes about a week for that to be done. So it allows us to work on the robot a little bit faster. But then even before then, or as for probably the bigger reason, is it allows for both driver practice to happen and programmers to have the robot, which has been super helpful this year. We've had the programmers just work on cycling, stuff like that, while programmers could really work on autos and odometry and all that other stuff with another robot. So it's been a huge help this year. Clay?
Something else that the 2 robots are having we call it a practice bot and a competition bot. Something else that enables is sort of the fork, making a revision. After Duluth, we wanted to try changing things, and we could implement those changes on the practice bot before we implemented them on the competition bot. So we weren't without a robot while we were making modifications, and we didn't undo a perfectly good working competition robot until we were confident in the design. Until we had proved out the design.
It also gives us another week to realize what might be a major oversight, in a sense of like, this year we thought about having 2 steel belly pans, which we realized very quickly was putting us like 15-20 pounds overweight. So that allowed us to have be time to take one off and add pocketing to it before needing to also take off all of the electronics and take off all the subsystems that were attached there.
Yeah, I guess I'd share that. Our experience with 2 robots was probably, this is our first year even trying it. And, you know, maybe it was just a learning curve thing, but we're probably not going to try to do it again. It was just too much, kind of double the labor, you know, I mean, just from that. And then of course, cost is always another thing. And it seemed like once the first one was put together, the second one kind of dragged a little bit. There was just a lot of emphasis getting that first one tuned in. Even though they were identical, it just seemed the first one done, software got their hands on it, we needed to iterate right away. And so I think what we're going to try to do is maybe have like a 1.5 and then a competition bot, and the 1.5 is mostly plywood or like a high fidelity prototype that's done early. So you can get software's hands on it early before you do that final iteration with, you know, your expensive metal and all that good stuff. I was trying to find videos of some of our plywood robot stuff. I might share some of that. And, yeah, so I guess that was our experience.
We did that this year, and like Sam said, well, when you especially a low budget team, it costs a lot. The reason why we wanted to do it was to get something out going. So we'd never had a swerve module for competition robot before, and being our 3rd year, we thought, hey, maybe if we got something out there with the swerve, and then our kids can be practicing driving. I don't think that we got that benefit very much so because of other logistical problems that I don't foresee going away in my school district. So the good that I saw in us doing that was, like, I think Clay or one of the No Method guys mentioned, was we were able to correct certain things that we perfected on our competition robot, but I feel like it's not cost effective, and it's something that we might just have to invest heavily on having someone on the team to effectively design a robot on Onshape and look at these different mechanisms and see how the geometry works, and then, you know, that there might be more cost effective for us and time wise too, because when you have 7 kids, 3 that shows up a lot more regularly, you don't want to burn it out building 2 robots, you know.
From a cost prohibitive standpoint, one of the nice things about having a second chassis is trying different mechanisms on it. And we've talked a little bit this year about making a sort of a dummy swerve chassis that instead of swerve wheels at the corners has got rotating shopping cart wheels, right? Idler wheels that can spin in every direction and rotate. And then essentially like a lawnmower handle on it. You know, the whole thing rolls along the ground and you can control it from up here. And it's like a bare frame and you can mount all kinds of stuff to it. You know, it's made of either 80/20 or, you know, something readily configurable. So you're not buying swerve modules. You're really just buying shopping cart wheels and some extrusion and ripping the handle off a lawnmower. And all of a sudden you got a thing you can drive around like a swerve chassis and bolt sub-assemblies to, or subsystems to.
Yeah, and the other thing with that is for the start of the year, actually even before the season started, we made a chassis with our swerve modules on it, and then we used that for the first bit of the year. It was not legal for use in competition, but it allowed the programmers to get hands on something and start working right away on autos and all of the fun stuff there. And so that was helpful.
I'd like to ask, kind of maybe a small pivot, is when you're assembling your robot, when do you decide that this needs to be redesigned because it's too painful to assemble or to fix, or if we have to do this reassembly in the pit, we're going to be miserable? Does anyone have any words of wisdom or their experience on that?
That is a really good question. I guess, let's see.
I have thoughts.
Yeah, go for it.
I work in manufacturing, and it kind of requires a thought to, at every step of the way, designing a mechanism. Anytime something changes, anytime you add something, you kind of have to pause and ask, how am I going to fix this? Like, when this breaks, how am I going to get to this thing that's inside this device? Or how am I going to fix it? And or how am I going to build it? And I'm not saying that that's like a, just do that and you'll be fine. It's an art. It's a muscle that you have to exercise. Something that, the more thought you can put into, even if it means changing the design entirely or changing how it's put together, the more thought that goes into how a thing is made, the better it is going, the easier it's going to be to make it, and the easier it's going to be to maintain it in the field. But I've heard stories from our team about that sort of issue where, we made this thing, and when it came time to fix it, we had to break out a circular saw to get into the thing to replace the broken part.
Yeah, and I think this is where prototyping is huge, because so I guess an example from the Mythic would be last year's robot, of where it might have been beneficial for us to pivot a little bit, but there comes a point where you're already too far into a design that it's very hard to make changes. And so I think specifically in that prototyping stage, asking that question of, is it realistic? Which we have on the pattern language for Nomothic that we were sharing earlier. But that's a really big one, is it accessible? Is it maintainable? And just sort of almost going through that checklist. I think that's a big one that Nomothic used this year. Yeah.
I have a question for the group.
Go for it.
When it comes to prototyping with powered mechanisms, something that runs off a motor, what is everyone's approach to like a fast, like how do you get to a spinning thing quickly? Do you are you using your your Neos and your Falcons and your like actual FRC motors, or are you using drills? And what's the ideal? What would you do if you could, as far as getting quickly to making a mechanism move? And do you have to involve the programmers and a Robo Rio, or do you are using drills so you don't have to? Thrifty throttles, etc.
Yeah, our team uses drills. I mean, they just recently discovered the magic of drills, but what they also do is some of the hex shafts that are put in the kit of parts actually fit in a drill truck. So one of the things we use is a drill with the kit of parts drill like hex shaft in it. And then the hex shaft is really nice because then you can put a lot of things in. A lot of things fit with the hex.
Go ahead, Eric.
Eric, I think you're muted if you're trying to talk.
Sorry. Okay. The Talon uses drills, but also if they want to put a motor on, they usually have ones they can talk to directly to a spark. And then they don't need a robo-relay or anything. They just will run the motor very quickly, just hook it up to the computer and run whatever speed they want out of it. So that's a second way that get things tested quickly.
A KnightKrawler will we put in a 1/2-inch bolt adapter into a drill so that you can slide it over the end of the hex shaft, and that's where we always start, is get out a couple of drills and you have a couple of students who are running the hex shafts either in opposite directions or same directions or whatever it is you're trying to do. And then we also have a PWM test board, so we'll pull out some old sims and we'll clamp them down in some way to a 2x4 piece of plywood, and then you can just turn that a PWM dial, a potentiometer dial, to be able to control that more forward and back. You can buy PWM controllers on Amazon really cheap, and then you can use old motor controllers that allow for PWM input, and then old brushless motors old brushed motors in order to set up a test rig. But we always start with drills. We try not to get the programmers involved in prototyping until we feel like we have something we'd actually want to cut on the CNC, which might still be plywood. But once we have a full kind of fully built rig, then we'll look at trying to hook it up to a robo-relay and have programmers involved.
Well, what we do, Talon, is we have our designers are usually very adept at running the sparks, so they don't need programmers around to do their testing.
I know that on No Mythic we've also made use of the thrifty throttles before to be able to test that sort of thing without necessarily needing as much from programmers. I'm not super knowledgeable about the thrifty throttles though.
Yeah. Let's see. I'm not seeing a whole lot of more thoughts on this. I guess question for y'all. When do y'all, so from prototyping, at what point do y'all switch from prototyping to fabrication of an actual system? Like, what do y'all sort of see as the cutoff there?
Jeremiah, do you have a comment on this? Go ahead. Otherwise, I'll jump into.
No. I have a question. You go ahead.
We've gotten to the point now where we will always cut something out of really thin plywood on a laser or 1/2-inch plywood on a CNC before we do anything out of aluminum and polycarb. We burned through too much material because we had the wrong size holes. We had them on the wrong spot. So even if you just take 1/8-inch hardboard and you run it through the laser and you cut it out just to see that it fits and it goes over the bumper the way you thought it would, or fits inside the frame the way you thought it would. So once we get a part in CAD, we will now almost always, I'm sure there's exceptions, but we'll almost always cut it out of scrap wood that we have before we do anything out of aluminum polycarb. In terms of when, if you're looking for a week number, it's always a week later than it should be. right? Schedules never work the way you want it to. I think that's also going to be a big part of our discussion this summer is, and I think this goes back to an April Tech discussion that seems to come up every week this year in these roundtables, is that April Techs has made it possible to do a lot of really cool things, but it has doubled the amount of time you need to do programming before a competition compared to just pointing at a piece of green tape on a screen and shooting. And so with the idea that now we need to give programmers even more time, how do we do that? If we want to be where we want to be by week 1, now we have to figure out how do we sacrifice something in the build process to get something to the programmers sooner. There's also the debate that, well, you can have programmers do all of that stuff with a test rig or test robot, but we all know that once you get the real thing, stuff comes up and things work a little bit differently. So anyway, the original question is always plywood and wood. We're usually not making real parts until week 3 or 4, which is a week later than we'd like to be making real parts.
I'll say on 2847, we've kind of similar to Scott, where we like to do it in plywood first, but I think this coming year we're probably going to actually do like CAD and do a CAD and then an actual cutout as like the first thing. I think we've started with 2x4s and kind of spinning shafts in random places in other years, and it's kind of really trying to think of prototype as more like testing that a CAD theory works or some packaging theory works, rather than just kind of seeing rather than, I don't know, kind of messing around. Or we've kind of ended up with these prototypes that kind of work, but they're also not dimensionally accurate. We don't really have the dimensions captured in CAD. So I think we're going to try to kind of CAD first. And then also, honestly, over the last couple of years, there's so much stuff on the Open Alliance and Chief Delphi and things. I kind of feel like you're spinning your wheels a little bit of, you take your entire team's capacity and prototype something, and then you can go out there online and find 50 teams. It's just the bandwidth is huge, and it's like, are we using our time well to make prototypes that are half as good as these and half as slow, or should we, lift from other people? I know in 2023 we kind of did our homebrewed kind of a clamping mechanism to grab the cones and cubes, and then by the time we kind of got it where we wanted it, then every bot came out, and it was like, oh, we should have done that, And so really trying to avoid that again of spending all this time and effort just to kind of make a mechanism that's maybe not firing as well as you'd want. That's kind of where we're at anyway. And then as Scott said, same thing. Do it out of cheap material, scrap material first, and then lock into your expensive polycarbonate aluminum and all that good stuff.
Yeah, Sam. I'm glad you said that, because I think was last year. No, well, so I thought the same thing in one of our. I think it was last year. It was our first year, because we had just started. It was Rapid React, and we have no clue. And so have been very limited. Everything. My kids didn't know where to start with anything. They don't know what FRC really is or any of that. And so, but I've seen some of these prototyping out there. So the way I did it was I used what I call my big fat Greek wedding method, and I just I'm like, I want you to try this, try that, try this, because I wanted them to replicate what other people have done and see if it works in their own space. So in a sense, they're still learning, something that they don't know how to do. And yes, the ideas were not original theirs, but however, the point is that you are expanding their horizon and their territory. And if that was not part of their repertoire already, and now it is. And so that's kind of how we were able to survive our first year, because our first year we didn't even know about Everbots or any of those other resources. Now that if you just starting out, now that's kit bots. So I don't think there's anything necessarily wrong with if somebody else already reinvented, someone has invented the wheels. No need to if that's idea seem to communicate with you, I don't think it's necessary to reinvent the wheel. Just try to make your kids to own up to it, how to make it work for their locate their space. Sorry.
I think that's a great approach. I agree with you that like lifting ideas from other teams that are freely publishing their information on Open Alliance or elsewhere, that's the point. That's the reason they're doing it. It's like, hey, this is what we did. This is what's working for us. Check it out. And it's such a great way to learn about what works and what doesn't by, seeing something that someone else has tried and then implementing it yourself. Yeah, so keep doing that. I do that in my daily life at my job.
If anybody else don't have anything else regarding that, I have a question to the group. So, question: what is the pros and cons? Well, I think I understand the pros about building your robot, and maybe we already addressed that, but I missed it. I was unsure. So, what are some cons about building within the frame of your robots, your intake mechanism, and those kind of, because we had a really good robot, sustained a lot of damage. I remember 1816 gave us a good whammer in St. Cloud, and we pretty much paid for that whole, from the practice field. It was one of our practice matches. We paid for that for the whole, event. We were still fixing things from that, impact collision. So, what, we're thinking about doing something within the parameter of our bumper next year, but we don't know what the game is yet. But again, they always involve you picking up something, carrying something through it, and shooting something or delivering it somewhere. So I figure it doesn't hurt to ask, what are the drawbacks and the benefits?
One of the drawbacks we experienced having an under the bumper intake up through our belly pan was we had that much less space to put stuff, to put electronics and motor controls and, the other stuff that crowds the chassis of the robot. We had to leave a big space about yay big to squeeze an orange note through, and rollers and deflectors and stuff.
Nicholas?
I think that it's also important to note the multiple ways to go about an under the bumper and over the bumper. Because, like, for under the bumper, you could have had the drive rail extension where you essentially just had another drive rail off of your main robot. And I know that a lot of teams had a tendency where that drive rail would bend inward after hard collision. I know that no Mythic, we just had it inside of our robot without that extra drive rail. And we ended up not having that bend inward problem as much due to having support, I think, along that whole beam. And then for an over the bumper intake, you could always design it in a way where I think Ultraviolet had a set fail point on theirs if they got hit, so that they could have a ton of extra parts of that specific part that would break to make repairs super fast when it did break.
Go for it, Eric.
I think you might be muted, Eric.
We're going. Our design team decided to do over the bumper, and that's decision. It had merits because they had an extremely wide intake. They were very efficient at picking up notes at full speed or anywhere around. They didn't even need to see it. So they had but yes, they did have to have spare parts. But I talked to our driver, decided, okay, yes, we're a little bit more vulnerable here. I mean, once we picked it up, we pulled it in. He says he avoided collisions. And I said, well, is that to protect the robot? And he came back, he says, well, every time you have a collision, that slows you down. So he basically, he drove not to hit anybody. So maybe overall he wasn't going full speed, but anytime he avoided hitting anybody, he says that gave him that much more time. So it was a mentality, I guess. And actually, we cycled extremely fast. Just having our intake being that efficient. And then, as I said, the driver just driving more intelligently rather than say, okay, hit somebody, if you hit somebody. But that was when he came back. He says, avoid hitting people because it slows you down. And we ended up with very few major hits in all the tournaments that way. But anyway, it was just a different look at doing things.
All right, let's see. Does anyone have anything else to add to that question? And does anyone else have any other questions? Because this is all the content that I was hoping to get to for this meeting. So unless anyone has any other questions, we might be able to end a little bit early today.
Well, I have a question that's not related to Rasmus's awesome topic tonight, but I'm curious if anyone had any unexpected observations out of champs this year. Did they see anything they didn't expect? Something that they think may play into the state tournament, perhaps? Anyone have any thoughts about what they saw when they saw the best teams in the world compete?
Yeah, I think defense will be huge. I don't know if y'all saw the finals matches on Einstein's, but defense was a huge role there, and especially in shutting down passing strategies and stuff like that.
I think something that we would never have anticipated week 1 or week 2 is the idea that you'd only have one robot scoring and 2 passing. That was unexpected. I think that you would we did that at 10K where we set up a robot so that we could pass, and so we had a button for passing. But the idea that you would have 2 robots passing, even in week 4, that was not something that we had considered as being a viable strategy until we saw it happen at champs. At least I shouldn't say I didn't feel that. Maybe others were smarter than me and observed that sooner than I did.
I enjoyed watching that strategy surface and then watching effective counter strategies surface shortly after it surfaced. The note poaching. I think Orbit did a really phenomenal job of, essentially hunting for the notes that were left around their opposing alliance's speaker and grabbing them. A note, getting a note and shooting a note gains you 1 point. Taking a note from in front of your opponent's speaker gains you a point and is a point that they're not going to score.
I'm really curious to see. There's very few teams at state that will be as like effective on the cleanup strategy as like a 254, let's say, or some of those strategies. And so I'm curious to see, if double passing actually comes to be. I think we're going to see some emulation of like world strategies that will not perform as well as just straight triple offense. We're going to see some passing that notes are going out of the field, getting stuck on the stage, where it's like you would have been better off just cycling. But I mean, I think in playoffs, the top alliances will be pulling it off, and there'll be some push pull between defense and double passing, single passing. I don't expect the autos to be quite as competitive. If anyone watched those autos in the finals, I mean, like 13-23, even picking them up out of the middle, spitting them out, and then picking it up later. I mean, that's just wild. And I think we're going to see more of a who can do a raw. Just who can do 6-note auto, who can do 7, maybe not quite as much race to the middle and collide, but we'll see. We'll see.
I saw some speed bumps that gave me like they were affirming, I guess. I'm new. This is my first year as a mentor, and have seen a lot of Robonuts and Cheesy Poofs and other recognizable robots. Just you see highlight reels of them doing a phenomenal job all the time. I think it was Robonut's first quals match in their division. I think they just went dark on the field 15 seconds in, and I didn't feel good. That didn't make me feel good. It just it was like, okay, this happens to everybody. We're all still just driving a robot that we built in the last 6 weeks or the last 15 weeks. Right?
One of the things that KnightKrawler learned from our champs experience was that we suffered from odometry. Just the speed that we had to go to get things, our odometry got off by a lot. Especially we spent most of our champs feeding other robots that could score because we had worked hard on getting code that would drop the notes in a pretty good place. Some of them went out of the field, and that happened because our robot lost its position on the field and it wasn't where it thought it was. And so it shot too far. So we will now have 4 April Take cameras on a robot for state and a Pixie cam for note acquisition. So we'll have 5 cameras on a robot. And hopefully we'll see better odometry. We'll see. It'll be interesting. Our programmer got it working yesterday. Had to do some fancy footwork with some parallel threading in order to process all the images and not have loop overruns, but Caleb was able to get it to work, or at least we got it to work in the gym. We'll see how it works when we're actually on the field.
Well, that's kind of the scary thing about state, right? Is that you don't get to try until you're in quals. that is your testing ground. There is no practice match, right? And maybe there is a practice match this year. I'm not sure, but.
Well, we talked about this too, because we had raised the question of, does KnightKrawler want to bring in some practice elements to help set up a practice field? And would it even make sense to bring in enough to set up half a practice field, bring our week 0 stuff? And we're like, when are you going to do that? Either the turnaround at state is so quick, there's just not enough time between matches to get out there and even use a practice field if you were going to try to run an auto or something like that. So, yeah, it's just, you have to figure it all out in quals. Yeah.
One question about that. I know there was some survey sent out a little while ago of if that first match should be a practice match or a qual match. Was it confirmed that that's a qual match?
I think that it was confirmed as a qual match. I could be wrong because I don't remember where I read that, but I think it was.
I can second that was confirmed as a qual match and that there will not be any practice matches, which is like, yeah, you get to get there a little bit of knocking on wood as you put the robot on the field for the first time.
I guess another thing that might be interesting is just probably with the C and quals, a bunch of teams having to play different strategies. You know, if you get 3 passers on a team, that's probably not going to work. If you get 3 cleanup bots on a team, so it'll be interesting to see like how that flexibility, you know, affects rankings, or if it does at all, or if, you know, some of the top teams are just good enough that it doesn't matter. They always full cycle, kind of like an Orbit did, and they say we're not going to mess with it until playoffs. Should be really fun to see. Excited.
I think this game, one of the observations that I made is that the highest performing robots really do depend a lot on their alliance partners in order for ranking. The highest robots, I mean, I was watching the rankings, and we get to the end and it's like, whoa, why is this team 14th? Why is this team 18th? Why is this team in the high 20s? And I think this game, at the highest level of competition, I think this game really puts a ton of dependency on your alliance partners, unlike previous years. I think this has turned out to be a very collaborative game in so many ways that I didn't anticipate.
I saw a behind the bumpers, and I'm sorry, I don't remember who it was, but it was someone who made it to Einstein this year. And they essentially had made the decision to surrender one of their drivers to be an extra human player. And forgive me if I get my words wrong here, but they basically wanted to be able to handle the amp and the source no matter what their alliance mates could do. And they sort of, it kind of looked like they did a little bit of like, hey, we're good at this, so let us do this, right? Because they were trying to avoid that that pitfall of, you know, ending up on an alliance with a team that hasn't read the rules or is, you know, unclear on the rules, or could get them in a bind. It's something that we experienced a few times at 10K. Our ranking coming out of quals was not where we expected it to be, and a lot of it was just out of our control. And on the flip side, you know, at Duluth, we did really well based on that, and I think a lot of that was in part due to the teams that we were on alliances with.
Well, I'm going to be curious to see like how the trap plays into ranking too, because at least at state, there will be more climbers than probably any event. Probably a higher percentage of climbers than Worlds, I would guess. And so you're going to see if those teams that can trap, are they going to be the only ones getting those, or, you know, is it going to be a kind of a common thing, or is it going to be kind of table stakes to get that, or is it going to be, you know, I think in week 1 it was mostly the trap bots, and at Worlds there was a pretty good mix, and here's probably going to be, if you just have a climber and you all execute, you know, the harmony and then the one harmony plus 1 basically. I expect to see a lot of that coming out, but we'll see.
We've had that conversation, and in Duluth we tried to trap almost every match, and we were only successful 2 out of those, and we redefined our trap mechanism a lot for 10K. And I don't anticipate you're going to see KnightKrawler attempt to trap unless we've got our note ranking point. What's that one called? Melody. And if we have the melody ranking point, and we have enough time, we may go try to trap. Or if there's no way we're going to win the match, and there's no way we're going to get the melody, then we may go try to trap. But I don't expect that we're going to trap very often, or attempt to trap very often at state. For the reason that you just said, Sam, is that hopefully everybody can climb, and we'll be able to focus on the harmony.
Did I read right that the melody threshold is the champs threshold? Like it's raised, or is it?
I thought it was district champs.
Oh, are there 2
right?
tiers?
Maybe somebody can confirm that.
18 and 21 says Nate. Is that?
It's up 3 from the normal one.
I can confirm 18 and 21.
Because at champs it was 21 and 25, wasn't it?
Oh wow, I didn't realize it went up twice. Okay, wild.
All right. Well, should we call it? It's 8:30, right in the nose. I think this was an excellent conversation, well worth having, especially this time of the year when everybody's thinking about it. Very timely topic. Thank you, Rasmus. This was a great conversation. I'm really happy that you proposed it. And so that's a great segue into please, someone else, several others, someone else's. Please sign up to host a conversation. I have set up a new sign up for the 4 weekends in May. Those are going to be the last 4 roundtables we do this year. We tried to do a couple over the summer last year, and it just really never worked out too well with everybody's summer plans and travel. And it got hard to keep track of which Sunday was the Sunday we were going to do a roundtable on. So I think we'll just do the 4 in May, and that'll be the end of it. So if you go to team2052.com/roundtable, all lowercase, you'll be able to find the link to host a topic, and you can use the sign up Genius form to host a topic. I know that I believe Sam Wieselman offered last week to do another coding topic. Is that right, Sam? If anyone had a topic they wanted to hear about.
Yeah. If there's suggestions or something people seem to routinely struggle with, definitely would be willing to. Yep.
And
I don't know if you want to coordinate, but our lead programmer, Rowan, is putting together a presentation on PID tuning and kind of the many different ways that shows up, but more like a hands-on, like here's how to use, Phoenix Tuner, here's how to use Motion Magic.
Okay.
And it might be nice to have like 2 or 3 people collaborate on that. I don't know if you'd be interested, Sam.
Yeah, absolutely. Yep. You can, I'll put my email in the chat and you can reach out for sure.
Awesome. That PID discussion that we had, that Sam gave a couple of weeks ago, was great, but doing something more hands-on, I think, would be even better. A second kind of sequel to that first talk. So that'd be great. Also, I suggested maybe doing a Blue Alliance API talk, and I actually have 2 KnightKrawler students who are interested in learning about that. So depending on their interest, I might throw at them my sample code that I've been using. Maybe the 2 of them will offer, or maybe I'll host it if we need a spot to be filled sometime in the next month. But if you have an idea of something you either want to present or just a discussion you want to have, please, by all means, please go sign up so we can get those last 4 slots filled up and we can finish our year strong. All right. With that, thanks, everybody. Thanks again, Rasmus. It was awesome. I'll see everybody next week.
Great. Thanks for hosting, everybody.